Hello, I'm Brian Young, and today we're going to be talking about 26310 voice data video. These are all the cabling and equipment that goes along with telephone, internet, intercom systems, even closed circuit TV. That all falls under this category, and in your code book you'll look at articles 810, 820. So let's take a look at the NCCER book 26310. Structured cabling systems. Backbone is a high capacity network link between two sections of a network. So you have a campus backbone and a riser backbone. We'll take a look at that in a moment. On page 1 on the right-hand side, the very first bullet talks about Category 3 cabling. Category 3, also called Cat 3 cable, with transmission rates of 16 megahertz, has historically been used for 10 megabit per second Ethernet networks. We don't use Cat 3 anymore. It just doesn't have the baud rate. It's not quick enough. They're talking about 10 megabit. We're into gigabits now, so it's very archaic. You may see Category 3 cabling that already exists. It's been put in a building. Here on page 2, they're showing a nice diagram down here that shows us, here's the campus backbone going from a main building to a separate building. Here's an equipment room. So you have the main cross connect and the equipment jumpers. Then the risers go from floor to floor, the riser backbone. However many floors you have, you'll bring the cabling system up to the different floors. A telecommunications room and an equipment room are the same thing, but usually a telecommunications room doesn't have large equipment in it. They can also call it the telecommunications closet. But if it has large equipment in it, then we call it the equipment room. The riser backbone comes up, and then you have horizontal cabling. This horizontal cabling system should try to be kept to a length no greater than 100 feet. You can extend it, but you have to put a box every 100 feet for pulling purposes. And then the very last work area station is the one that comes out to your desk and goes to the jacks, and you plug into the jacks and go to your computer and your telephone. And here they are. It has the campus backbone system, outside plant connectivity between buildings in a multi-building campus environment. This cable, this includes the entrance for each building. And then you go up to equipment room subsystem, the riser subsystem, the horizontal cabling subsystem, and then the work area subsystem. This is the last, like the branch circuit that goes to your desk. The telecommunications outlets at the end user location and the associated patch cables providing final connectivity. So when you plug in to an Ethernet jack at your desk and plug it into your computer, that is the work area subsystem. Interduct, we're talking about over on page 3, environmental protection. So if you want to know more about the campus backbone system, that's that main trunk line that connects buildings in a multi-building campus. That main campus trunk line has to have labeling, all campus backbone subsystem cabling, protection blocks, conduit, interduct, handholds, and pedestals, they all have to be labeled. The cable has to be labeled within 12 inches of the termination point. Protection blocks at the top center of the front cover, conduit within 6 inches of the termination point, and inner duct within 12 inches of the termination point. So cabling and inner duct systems within 12 inches of the termination point. Down at the bottom of page 4, talks about the equipment, the telecom room, telecommunications room. Hold on a second, I've got things in my way here. The telecommunications room, the following are general safe distance clearances for the telecommunications room or telecom cable. You want to stay 48 inches away from motors and transformers. This is true with any cabling system, the riser cable, the horizontal backbone, any of the workstation cabling. You want to keep 48 inches away from motors and transformers. 12 inches away from conduit and cables used for electrical distribution. This is for your lighting system or for receptacles. Keep 5 inches away from fluorescent lighting. They cause interference. They can induce a small voltage and current in the communications cable. And that interference will scramble the message that you're trying to send over the cable. This is electrical non-metallic tubing. ENT, when they first came out with it, it was all blue, so we called it Smurf tube. So you might hear someone refer to Smurf tube on the job. It's electrical non-metallic tubing. It's flexible, it's corrugated. It's, I don't like it. I mean, it's difficult to work with and hard to get a fish tape in. Here are some nice images over on page 6 of trunk lines. That's nice work. Someone took the time to line all these cables up and to put zip ties around them and to make it look professional. This is a very professionally done job. That's good. That's nice. When you are in the trade and you're doing work, know that people are going to see your work and try to do very professional work like that. Environmental protection on page 7, right-hand side, down at the bottom, last indented paragraph says, any penetrations through walls or floors that are required for the riser pathways must be neatly sleeved and fire stopped. Fire stopping keeps oxygen from traveling from room to room. So if there is a fire, you can starve the fire of oxygen in one room. You don't want open breezeways where that fire can get a good source of oxygen from outside air. So any penetration through floors, through walls, we will fire stop. It's almost like a caulking that you fill the tube with the chase, the sleeve, and then it hardens. Some are putties that you can mold with your hands. Some of them are caulking that you put in a caulking gun. It's a fire stop. I have nothing on page 8. It has a lot of good information on the different types of cabling systems, the different ratings of cables, category 3, category 5, category 6. You can take a closer look at that. On page 9, they're talking about workmanship. The riser support structure and cable must be straight, level, and plumb. Use sweeping 90-degree transitions with strict adherence to the cable manufacturer's bend radius. Cables should be dressed cable for cable and end to end as much as possible. Cables must be neatly bundled with tie wraps, Velcro ties, or approved cord. So there are people who use cord. It is similar in appearance to dental floss, but you can lay your cables in a cable tray and you can tie them individually. It's time consuming, but when you get done, it's a very nice looking job. Here on page 9, right-hand side, very bottom of the page, very last sentence, horizontal trunks should cross perpendicular to fluorescent lights and run no closer than 5 inches. Keep telecom cables 12 inches, and then on the next page it says away from electrical power cable or conduit, and 48 inches away from motors or transformers. So that's the same requirements they had on the backbone riser. You need to stay 5 inches away from fluorescent lights, 12 inches away from electrical power cables or conduits, and 48 inches away from motors or transformers to prevent interference. So here on the bottom of page 10, left-hand side, it says horizontal conduit or stubs, that's a sleeve-through wall, should be run in the most direct route possible, parallel and perpendicular to the building lines. They should be located a minimum of 48 inches away from motors and transformers, 12 inches from conduit and cable used for electrical power distribution, and 5 inches away from fluorescent lighting. So deja vu all over again. That's the requirement for all of these different types of runs. They should contain no 90-degree conduit bodies, like an LB or an LL, and no continuous sections longer than 100 feet. So if it's longer than 100 feet, you need to put a box every 100 feet. And you can use a pulling C that goes in and out in a straight line. They don't want you to use an L conduit body. Over on page 11, left-hand side, support structure. It says the support structure for a horizontal subsystem can consist of J-hooks, bags, bridle rings, and ladder rack trays. So that's the different types of things you can use to suspend the cable from the building structure. You can use J-hooks, bags, bridle rings, and ladder racks or trays. Over on page 12, right-hand column, top of the page, it says wall phones should be mounted 48 inches above finished floor. That's AFF. Using a stainless steel 8-pin modular faceplate. When routing cables, maintain the following standard separation: 5 inches from fluorescent lighting, 12 inches from conduit and cable used for electrical distribution, 48 inches from motors and transformers. So they keep giving us that same requirement: 5 inches from fluorescent lighting, 12 inches from electrical cables and conduit, and 48 inches from motors and transformers. Okay, on page 15, installation and termination of cable systems. Page 15, left-hand side, bottom of the left-hand column. They're talking about unshielded twisted pair, UTP, and coax cable. Unfinished twisted pair. So the shielding blocks crosstalk, and it blocks interference from electromagnetic radiation. That's one of the reasons why we stay away from transformers and motors 48 inches, because of that electromagnetic radiation. You have magnetic lines of flux coming out of those items, and it's going to interfere. It's going to induce a voltage and a current, and we're talking about very, very low currents. So any kind of an induced current will scramble the message that you're trying to send on that communications cable. So unshielded twisted pair jacks and plugs. RJ means registered jack, like an RJ45, RJ6. That's a registered jack. On the right-hand column on page 15, it talks about the different, it talks about the two different schemes, A and B wiring. We actually use B wiring today because of AT&T. However, the most popular method used today is the B scheme because of the continued interface with AT&T equipment and systems that use the B scheme. So way back when they had the two schemes, AT&T grabbed the B scheme, and this is what they mean. You have a, an, a 4-pair twisted pair, and it's how you arrange them in the jack. Here they're doing pair 3, and then they're saddling pair 2 over pair 1, and then they're doing pair 4. The B scheme, the one that we use today, has pair 2 first, then pair 3 is saddling over pair 1, and pair 4 is at the end. It's a way of reducing crosstalk in the cables. When you have 4 twisted pairs, when you have 8 conductors lying in the same cable, there is a danger of having crosstalk. If you've ever been on the telephone talking with someone and you could faintly hear someone else's communication, that's crosstalk. So rather than, the worst scheme is when you nest all of them and you put pair 1 in the middle, and then pair 2 saddles that, and then pair 3 saddles pair 2, and pair 4 saddles pair 3. That's the worst type of scheme that you can do. But you also don't want to just put pair 1, pair 2, pair 3, pair 4. So having this pair 3 saddling over pair 1 is a way to reduce that crosstalk. And if you look at the colors, pair 2 is white with orange and orange. And here's the terminal point 1 and 2. White with orange, orange. Then pair 3 is white with green. And then we jump into pair 1, blue, white with blue, green, white with brown, brown. So again, and I don't know why they're saying brown with white, because they're not going to put white on it. They're just going to have a solid brown, a solid blue, solid orange, solid green. But it goes white with orange, orange, white with green, blue, white with blue, green, white with brown, brown. 1, 2, 3, 4, 5, 6, 7, 8. Notice that pair 1 is actually reversed in its polarity. The negative is on the left, the positive is on the right. The other 3 have their positive on the left and the negative on the right. But they've switched the polarity. They've switched the polarity in order to reduce that crosstalk in the cabling. So we use the B scheme. Today, most straight-through patch cords for Cat 5, Cat 3, Cat 5e, and Cat 6 are wired to the B scheme. This RG6 F type of coax cable for installing an F type compression connector on RG6 coax. So if they ask you what type of a connector you use with RG6 coax cable, it's an F-type compression connector. An F-type compression connector is used to terminate RG6 coax cable. Here on page 17 are some of the tools that we use in order to punch down cables on a punch down block. Fiber optic cable can consist of a 2-cable duplex. Single cable is a simplex, 2 cables duplex, multi-cable is multi-fiber. The one they want you to be aware of is the duplex, which is 2 cables. So simplex, duplex, or multi-fiber. And that's on the bottom of the right-hand column of page 17. Page 18 is nice. They go through step by step. They show you pictures. They tell you what you need to do in order to terminate. And I think that's an RJ8 for 4 conductor, 4 twisted pair. It's 8 conductor, 4 twisted pair. And then over on page 19, they talk about the tools required to terminate coax cable with that F type of jack. Page 20, page 21 on the left-hand column It says long vertical runs should be clamped every 3 to 6 feet. This is installation in cable tray and ducts. You need to clamp it every 3 to 6 feet. And on the right-hand column, it says also pull boxes should be located in any area where the conduit makes several bends that total more than 180 degrees. With electrical conduit, we're restricted to 360 degrees, but for telecommunications, they cut that in half. They say 180 degrees. If you have more than 180 degrees in a line, then you need to have a box. Here on page 22, they're saying for fiber optic cable, you can save a lot of money. A standard universal telephone enclosure can also be used to house spliced fiber optic cables. So you can use a fiber optic cable box, or you can use just one of these telephone enclosure box. And here's a good example of phone cables coming down and terminating on a terminal block. I've got nothing on page 23. 24. On the left-hand side, very bottom of the page, says the minimum size grounding electrode conductor for communication circuits is number 14 per NEC section 800.100A3. The length shall be as short as possible, not to exceed 20 feet in 1 and 2 family dwellings per NEC section 800.100A4. So we want to keep it within 20 feet. Fiber optic cable is an NEC section 770, Article 770. So I highlighted the 770s there. Fiber optic cable is in Article 770. And on page 26 on the right-hand side, it says Category 5E tests include equal level far end crosstalk, ELFEXT, equal level far end crosstalk. Know that near end crosstalk is NEXT, near end crosstalk. So power sum next up to 100 megahertz. So the Category 5 tests include the equal level far end crosstalk and the near end crosstalk. This concludes our discussion on 26310 voice data video. If you have any questions, consult your instructor. And as always, work safe, work smart, and use your PPE. That's what it's there for. Thank you.